What's going on, guys? Let's look at this problem right here. Here we have a first order differential equation, but this is not a linear differential equation because of this y square. This is not linear. Now we can make this one linear if we rearrange this one a little bit. Now let's see how to do that. First of all, what I'm going to do is I'm going to separate, I'm going to bring this dx to this side. Okay, if I rewrite this one, it's going to be dx over dy. I'm bringing both, I'm just switching up. Okay, so if I bring this to this side, it's going to be x plus y square, and if I bring this x to this side, this is going to be dx over dy minus x is equal to y square. Now this is a first order linear differential equation, but this is not in terms of y, because if you look at this one, the standard form of the linear first order differential equation should look like this. It should look like dy by dx plus we have to have a function of x multiplied by y that's equal to a function of x. This is the standard form of the first order linear differential equation. But if we want to write this one in terms of x, it can be written as opposite way, like dx by dy, and here we can have p of y multiplied by x and q of y. That's what we did right here, because if we write in terms of y, this is not a linear differential equation, so we cannot use the usual method to solve this one. So if we want to solve this one using linear first order method, we had to have a linear first order differential equation. So what I did was I rearranged everything in terms of x, so we can create a linear first order differential equation, then we can solve for this. Now for this one, we have to find out the integrating factor, because this is now in standard form. Now we have to find out the integrating factor. Integrating factor equation is mu is equal to e power integral, usually it's p of x dx, but since we arranged everything in terms of x, here we have to use p of y dy. Okay, p of y is the value that's multiplying this x. Now here we have negative, it should be positive. Since we have negative, we have to take the negative, and we don't have any function of y right here, so this is just -1. So p of x is just p of y actually is -1. So we had to use that one in this equation to find out the integrating factor. Mu is equal to e power negative integral of -1 dy. If you integrate -1, that's going to be just e power -y. Okay. Now this is our integrating factor. After we find out the integrating factor, we have to multiply both sides of the equation by integrating factor. So e power -y, if you multiply the whole thing by integrating factor, you will get something like this. So this is going to be d of dx e power -y over dy minus x e power y square and e power -y. Now if you look at this one, if I find the derivative of this one, this will give the whole thing. That's a product rule. That's why after multiplying by integrating factor, we can just take this first part alone and equalize to this one, because if you take the derivative of this one, that's going to give us chain rule. This is the one, d over dy in this case, dy x e power -y. If you do the derivative for this one, you will get the whole thing back. So this is equal to this one. Therefore, we can just directly equalize this one to this one, y square e power -y. After we multiplying by the integrating factor, we have to integrate both sides. Usually we do with respect to x. Here we changed everything in terms of x, so we have to do with respect to y. Okay. Here derivative and integral cancels each other, so this is going to be eliminated. Okay, so for this one, this is x e power -y, but for this one you have to do the integration by parts. But you have to do this one twice. For this one, if you do it twice, you will get this one, negative y square e power -y minus 2y e power -y minus 2 e power -y plus constant. So this is the one you will get after do the integration. Now let's get rid of this one and continue here. Okay, here what we are going to have, let's continue here. So here we have to write everything in terms of x. Usually we do in terms of y, but since we write everything in terms of x, like we changed everything in terms of x, we had to have the final solution in terms of x. So to have this one in terms of x, we have to divide everything by e power negative y, e power negative y, e power negative y, e power negative y, and this one also e power negative y, and c also divided by e power negative y. If you divide this one by e power negative y, that's going to be just x. In the other side, we will have negative y square minus 2y minus 2 plus constant divided by e power negative y. Okay, now this is the one we are having right now. The next thing is, so we can also move this e power negative y to the top, because if it's in the denominator, it's equivalent to e power y. So x is equal to minus y square minus 2y minus 2 plus c e power y. So this is the general solution for this differential equation. But here we have an initial value, right? Initial value provided. So we have to find out the particular solution. So to find the particular solution, first of all, we have to know this is our x value and this is our y value. So let's go ahead and plug it in this equation to find out c, because we had to find out the c, then we have to plug it back in this equation and express our final answer. Now let's go ahead and do that. Here we know that x is equal to negative 2. Let's replace that one. X is equal to negative 2, y is 0. So first one is going to be 0, and second one also 2 times 0, 0, minus 2 plus constant e power 0. So we are left with minus 2 plus c, e power 0 is just 1, so we can just leave it like this. Therefore c is going to be equal to 0. If c is 0, our particular solution for the differential equation is going to be x. Let's use a different color. X, that's equal to negative y square minus 2y plus 2. Not plus 2, it's minus 2. Okay, let me erase this one. Okay, here we have to have minus 2. This is minus 2, and then constant is 0, we found out. So that's it. Since constant is 0, after that it's going to be 0. So this is going to be the particular solution of this differential equation. And that's it. I hope this helps. Thanks for watching, and don't forget to subscribe. See you next time.